Hello and welcome to our section on pedology, or the study of soils. Now, soils are important to human life for a number of reasons. Firstly, they harbor nutrients such as carbon and nitrogen. Secondly, they are a medium for plant growth, allowing us to feed the world. Thirdly, they store a lot of water in the form of groundwater. And lastly, they are a surface for building structures such as roads and the house or apartment that you live in today. Now, the components of soil can be remembered through the acronym MOMA: minerals, organic matter, moisture, and air, the latter two falling under the category pore space. Now, minerals are the rock fragments that were either weathered from rocks on site or transported from somewhere else through erosive processes such as wind, water, or mass wasting. And they are what contribute to soil texture. Now, the three key minerals in soil are sand, silt, and clay. Uh, Gravel is another mineral that can be mixed in. However, it is much larger than the other three key minerals. Sand is the largest of those three key minerals, with silt following after that, and clay being invisible to the naked eye. Now, using this soil texture triangle in the right of the slide, you can determine the texture type of the soil based on the percent composition of each of the three minerals. For example, if I had a soil with 60% sand and 10% clay, meaning that it would have 30% silt, I would be able to determine using just this laser pointer here, 30% clay, 10% or 30% silt rather, 10% clay, and 60% sand, that I am in the sandy loam category of soils. Now, organic matter is also very key to soil formation, which we will talk about more later, and it is composed of both organisms like nitrogen fixing bacteria and worms, for example, as well as dead detritus from trees like leaves from deciduous trees in the fall, or branches that fall off of the trees in windstorms. Pore space is also very important to soil, specifically for groundwater, as with larger pore spaces uh, and more connected spaces, groundwater can seep into the soil, and the soil can harbor large reserves of this groundwater. Now, sandy soil transports water most efficiently, as the pores in between it are larger since the particles are so large. However, clay soil does not transport water as well. Um, so, a mix of the two, for example, for plant growth, is preferred as uh, or a loam is preferred, as you don't want the water necessarily running down through the soil completely, but you also don't want the water just sitting on the surface and drowning your plants. Soil structure is determined through the horizons of the soil and the composition of the beds or aggregates. Now, a bed is essentially a mixture formed from sand, silt, clay, and organic matter. A bed will be more cohesive with uh, more clay, as the pore spaces are not as big, and also more cohesive with more organic matter. The horizons of the soil are divided using a diagram similar to this in most cases. So the O horizon is the organic matter, such as leaves, dead logs, and so on and so forth. Essentially, the accumulation of organic matter at the surface. A is the surface layer. B is the subsoil. C is the substratum, and R is the bedrock of the soil, or the rocky layer below it. Now, some soil forming factors include climate, like temperature and humidity, and this determines how much water is in the soil and also what plants can grow on the surface of the soil, which affects the next factor, the organisms uh, that are present in the soil. For example, do the trees drop a lot of leaves, creating more organic matter, or are they coniferous, which who with acidic needles, uh, making the soil more acidic. The relief also affects the soil uh, as it creates both a microclimate with possibly more rain or less rain, depending on the rain shadow, uh, and can also contribute to the amount of soil in portions of the cliff. For example, if there's high relief, there's likely to be less soil because of mass wasting processes, whereas downslope, there will be more soil as the mass wasting has brought the soil to that area. Parent material may not be the bedrock, however, it is in most cases. The only reason that it may not be the bedrock is due to erosive processes or mass wasting. But if it is the bedrock, then there's a correlation between the bedrock type and the soil texture. For example, bedrock, if the bedrock is shale, then the soil is more likely to be clay prevalent because shale is a rock formed from clay minerals. Time obviously allows the soil to build up, and humans can impact the soil by putting nutrients into it through fertilizers, as well as compacting, irrigating, and uh, desertifying the soil through processes like climate change and uh, overgrazing. All of these factors can be remembered through the acronym CLORPth. Some soil orders in Canada include the Brunozoic and Luvizoic soils in southwestern Ontario, the Glazoic soils or waterlogged soils, which are prevalent in wetlands, the Chernozemic or prairie grassland soils, Podzoic soils, which are acidic forest soils, which are prevalent in the boreal forest as the organic matter there or the trees on the surface drop their needles, which are acidic. uh, Solonetzik soils are salinized and are prevalent either on coasts or in inland environments with high rates of evaporation. And then cryozolic soils are permafrost, obviously prevalent in the Canadian North. Now, a good exercise would be to go through all of these pictures and identify which soil type corresponds to which number.